Data Skeptic is the official podcast of dataskeptic.com, bringing you stories, interviews, and mini episodes on topics in data science, machine learning, statistics, and artificial intelligence.
So, Linda, today I want to talk about generative adversarial networks, and more specifically, generative adversarial learning, I guess would be the broader way of describing it. Any guesses as to what that might mean?
Well, adversary, there are people against each other competing.
Yeah, in a way, it's exactly what's going on here. So in a generative adversarial network, what you have is sort of like traditional machine learning. You have one system that's trying to recognize stuff, like maybe decide if a particular photo has like a bird in it or not. That would be a cool problem to do with machine learning. What's different in this situation is the adversarial network is there. So if we take that traditional approach that we're trying to use machine learning to do some image recognition, we could call that a discriminator, right? It's trying to look at new pictures and discriminate whether or not they have the feature you're looking for.
So you're trying to find something in the picture.
Mm-hmm. Like, does the picture contain a bird? Yes or no? And then the new idea is let's make something complementary to that called a generative network, or it's the adversarial network. And what it does is it looks at the machine that's, trying to see if there's birds in pictures or not. And it says, how can I fool the first network? How can I make an image that doesn't actually contain a bird, but tricks that into thinking there's a bird?
So they're just putting one to the test?
Mm-hmm. Well, a little bit more than that. Their goal, they're making it their job of trying to fake that system out. Maybe we should talk about art forgeries. You have a pretty good background in photography, right?
Yeah. I like photography.
I was going to talk about Ansel Adams, but I feel like that's the only photographer anyone knows. Who's another photographer we could talk about?
Cindy Sherman.
Cindy Sherman. All right. Have you seen every single photo Cindy Sherman's ever taken?
No.
But if you saw a new photo and I ask you to guess, do you think it's a Cindy Sherman photo or not? Could you have a pretty high accuracy doing that?
I don't know. We could always put it to the test.
We could, yeah. Presumably you could tell her photos apart from Ansel Adams' photos pretty quickly, I assume, right?
Yeah, well, one's landscape and one's portrait.
Okay, so there you go. That's easy. So then if that was all you knew, let's say you were trying to teach me and I know nothing about photography, you could teach me that fact right there. If it's a landscape, then it's not Cindy. Now, if I was an adversarial generative network, I would say, okay, well, let me find a new picture that isn't a landscape and is a portrait and show that and be like, what do you think of this one? Is this a photo from Cindy? And as far as I know right now, Kyle can't distinguish. I don't know the qualities of what make a photo by Cindy or not.
Mm-hmm.
So you could fool me by just showing me any portrait. So teach me a little bit more now. What else do I need to know to recognize it's one of her photos?
Well, usually she photographs herself in them, posing in a staged way.
Okay, interesting. So that's not going to be a little hard because she has a little bit of control over who photographs her. So it would be hard for me to find just any old portrait, but maybe someone saw her in public and they snapped a random picture of her. And then maybe I myself couldn't tell the difference between that and one of her official photos. So give me some more advice. How might I now learn the difference between a paparazzi photo of the woman and her actual artwork?
Well, if she's dressing up like someone, she'll have a prosthetic nose and whatnot. So she actually modifies her face.
Oh, well, that
sometimes.
Interesting. That almost makes it easier now for me to make the fakes. Perhaps I could get with some Hollywood effects designer and we could find a model that, an actress that looks a lot like Cindy, close enough, and we dress them up and then I submit that. At that point, it's kind of a forgery, right?
I don't know. I feel like the term forgery is used with money because you're trying to fake someone out. And also you have some percentage of success. I'm not sure if you would have much success.
Actually, you're right. And I have an interesting side fact about that. I learned that it is not illegal to make a forgery. It's just illegal to sell one. Mm-hmm. Which at first surprised me, but then I kind of get it. Let's say I wanted to learn how to paint like Van Gogh, and I did it by trying to reproduce his paintings. That's just teaching, right? That shouldn't stop anyone from doing that.
Right.
But if I tried to be like, hey, this is an actual Van Gogh, I can't tell you where I found it, but it's for sale, that would be illegal.
Yeah, I think forgery is the act of trying to make you believe it's something. So that is what you're trying to do?
No, I'm full. I'm not. I plead the fifth.
Okay, he's not admitting to
Yeah.
forgery.
I'm more of a discriminator than a generator in the generative adversarial network sense of the word here. So let's get back to that. If you have a pretty typical neural network type problem, you're trying to learn how to recognize maybe these photos by, what was her name again?
Her name was Cindy Sherman.
Yeah, Cindy Sherman. So I could start to imitate her photos more and more. And if I made this my main pursuit in life, maybe eventually I'd get to the point where I could give a photo to you and you wouldn't be able to tell if she made it or I made it. Do you think that's possible?
Yeah, I mean, definitely a lot of trial and error and learning.
So what would I be learning? Would I be learning her style or just learning how to fool you?
Both.
Yeah, actually, I think it is both. And that's an important distinction about generative adversarial learning. So how it works kind of from a more mathematical point of view. You have some set of labeled photos. Now, of course, one of the problems when you work on deep learning is oftentimes you don't have a big enough corpus of data. So this can help with that. So let's say you have maybe 100 photos she shot and 100 photos that are just like random photos off the internet. So the discriminator network is trying to learn, well, what's unique about her photos that it can try and use for predictions in the future. But the generator network, the adversary, what it does is it looks at the discriminator and it says, how can I maximize the error it makes? How can I produce a new photo that is going to make that network screw up and misclassify it? At first, it could just submit any photo. And then the discriminator network will start to recognize like, oh, I can see, your fakes are low resolution or they don't contain these certain qualities or there's, what about the fakes is distinguishable that I can say those aren't the class I'm looking for?
What is it that's distinguishable that aren't what you're looking for?
Mm-hmm.
It's your exclusions.
Yeah, in a way.
Okay.
Yeah. So now you have these photos, the legitimate ones, and a set that were created, they were generated, they're totally fake, but they were generated with the attempt to fool you, to make you make a mistake. Maybe you look at them and probably the earliest forgeries are a little bit obvious. There's something clunky or like, often grotesque about them. But then these two networks, even though they're sort of adversarial, they share information. So they'll pass kind of a copy of themselves back and forth to each other. So the generative network will be like, oh, I'm pretty accurate. I can recognize all of your fakes. And here are the weights of my neural network. This is how I do it. And then the generator says, okay, let me look at your cognitive process, if you allow me to call it that, and then say, how can I produce a new set of images which you would have a harder time distinguishing? And then that's the next round. I give you these slightly better forgeries, and you have to learn to be a little smarter at recognizing and outsmarting me with whatever I've done with the new forgeries.
Okay, so it sounds like you're just getting active feedback.
Yeah, it's this really kind of cool cat and mouse game.
That's good.
Yeah, it's actually a very modern idea. As far as I know, it was introduced into the literature in 2014, so it's a new concept, but it's been having a lot of great success because it allows you to do learning without introducing new labeled data. You're actually creating all these examples that help make your system a little bit smarter.
Have you used this?
Me personally, I have only toyed around with this. I haven't deployed anything or, brought it to a client or anything like that. But
how come?
Because I don't do that much image recognition problems right now.
Oh, so it's specific to image recognition.
That is where the majority of the literature is, but this concept actually could be used everywhere. I have some audio work I'm doing now that I'm actually going to present the public portion of in a couple of weeks at a meetup. So people should check dataskeptic.com if you're in LA and you want to go to that. And I might apply some of it there, but in theory, this concept could work anywhere. You could always apply the general idea of how do we make new example data sets that can fool our system and then ask the system to get smarter by improving and learning to recognize the fooling images. So we're going to talk about adversarial networks for a couple of weeks here. Next Friday on Data Skeptic will be an interview with two people who produced actually a novel extension to this. So I don't want to spoil that, but stay tuned for a really cool interview on generative adversarial networks next week. And between now and then, I just want to remind everyone to keep thinking skeptically of and with data. Thanks as always for joining me, Linda.
Thank you, Kyle. Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.